Welcome to Brain Vision.
Looking at structural analysis, consider the problem at hand. We'll want to determine the maximum force P that the structure can be loaded with. Okay, and to solve this problem, we'll apply the method of joints. Okay, to, to solve it. So, but before that, let us look at the support reaction. For the support reactions, you can see that the structure is symmetrical. Therefore, the reaction at A is going to be P over 2, and the reaction at C is also going to be P over 2. Okay, so we can look at the joint A. So we'll apply the method of joints. Okay, so let us look at joint A. If you look at joint A, you will discover the forces. There's this force here, okay, and this force coming. Now, this is our joint A. Now, you are going to determine the angles using the information given in the question. To do that, okay, you can call this, because it's coming out of the joint A and going to another joint B, call it F sub AB. Now, this angle is inclined to 45 degrees, okay? So use the information given in the question, in the structure there, to do that. And we have another force like this, okay? This one we can call it this is F subscript A AD, and the angle there is actually 14 point. If you find it out, you are going to arrive at 14.04 degrees. Okay. Now you can apply. Of course, this is what we got. Not quite long, P over 2 for arrow substrate A. Okay. So we can take summation of forces in the vertical direction. Okay, to be 0. So when we do this, we are going to arrive at P over 2 plus F substitute AB sine 45 degrees, okay, plus F AD substitute AD, okay, sine 14.04 degrees to be equal to 0. We can call this equation 1. Okay. Then if we take summation of forces in the horizontal direction, we are going to have the forces are going to be, just use the diagram. That's why the diagram is there. You have that force F substitute AB. Okay, when you resolve it, it will give you cos 45 degrees. Okay, in the horizontal direction, we said it, F subscript A AD cos 14.04 degree is equal to 0. You can call this equation 2. Okay. Now, if we solve these two equations and we consider equation 2, making FA AB the subject of the formula, okay, we are going to arrive at FAB to be equal to, plugging in the values of your cosine, whatever, all the values you need to put in, 372. Okay, we are going to arrive at this value, FAD. Okay, now you can plug this back into equation 1. Okay, when you do that, you are going to arrive at your FA AB to be equal to minus 0.9443 P. Okay, 0.943 P. You can see that this member has a negative sign attached. So it's a member under compression. Okay, that's the nature. Now we can look at another joint. Let's take joint B. Let's call it just for short JB. Okay, we have this force coming like this. We have this force coming straight down. We have this force. Okay, now if you check the forces, check the diagram. Okay, use the information, the figures, dimensions given in the diagram. Okay, you will have you will have this angle to be actually 45 degrees. This angle is going to give you 45 degrees. Okay, these are joint B. We said the forces should be coming out of the joint, except those that are naturally going in. So we are going to have this one to be also 45 degrees. Okay, so just use the information given in the question. Uh, this is going out. This is FB or F subscript BC, and this is F subscript BD. Okay. Now, if we take summation of forces in the horizontal, summation of forces in the horizontal direction, we are going to have minus F B A subscript A B subscript F subscript B A cos 45 degree plus F subscript BC cos 45 degree to be equal to 0. It's going to be equal to 0, so that when you solve this out, you are going to have F subscript BC to be equal to minus 0.943 P. Okay, 0.943 943 P. Now you can see that this member is a member under compression because of the negative sign and indication of. Okay, then we can continue by looking at joint D. If you look at joint D, let's call it JD, joint D. Okay, we are going to have the forces going to look like this. Okay, this one coming down. This particular force, we said the forces should be coming out. Okay, this is F B A. Okay, and this angle is inclined to 14.5 14.04. Use the information given in the diagram to get it. These are joint D. Same thing. This one is 14.04 degree. Okay. These are F subscript. DB going to joint B. Okay, these are F subscripts. DC, this is A. DC, these are P. Yeah. So we'll take summation of forces in the vertical direction. Okay, we are going to have that. We are going to have F dB minus P minus F dA sine 14.04 degrees minus F BC sine 14.04 degrees is equal to 0. So when you solve this out, considering, if you check the information given, you will discover that from the question, you will discover that FDA, F subscript DA, is equal to F subscript. The maximum value we are talking about, okay, for those members under tension, as given in the question, that they are equal to 1,500 IB tension. Okay, so if we put this in mind and consider this equation here, we are going to arrive at F subscript D A. You can take any one, either S subscript DA or S subscript DP or S subscript DC, since they are equal, to be equal to P. And it's going to give you tension. Okay, now if we consider this particular equation, okay, now if we decide to put our 1,500 into our 1,500 IB here, okay, here we are going to arrive at P to be equal to 1,500. Okay, now IB. Now if we decide to put this P into the other equation that we got, which is this equation, okay, into this equation, FBC is equal to 0. FBC and FBA equal to 0.943P. FBC FBA into FBC equal to FBA is equal to 0.9 minus 0.9433P. If we put this into this, we are going to put P as 1,500 here. We are going to arrive at BC, which we know is also equal to FBA, to be equal to 1,414.5 IB. And of course, we know that this does not meet specification, so it's greater than the 800 given. So what we will do, we'll apply our 800 into this equation. Okay, if we apply 800 here into here, we can have our P. We will have P to be equal to 800 and child minus 848.36 IB. Okay, so it's negative, just trying to tell us that the force is coming down. Okay, so the value there is actually, okay, it's actually P is actually equal to 848.36 IB. So this is the maximum force that the structure can take.